Hello, in these last chapters for the semester, we'll be covering the two-factor analysis of variance and correlations. Now, we won't be covering any calculations for these, but a lot of conceptual information, so that hopefully if you go on, you have a good understanding of what a two-factor analysis of variance is and how you would interpret that information, as well as how correlation differs from these other analyses. So in the last chapter, we went over an independent measures ANOVA. So these independent measures ANOVA is used when we have a between subjects design, and it evaluates the mean differences for two or more groups. So we can use, remember, a t-test if we only have two levels of an independent variable. When we have three or more levels, we need to use an ANOVA, or an analysis of variance. The analysis that we did in the last chapter was limited to one independent variable, so one independent variable with two or more levels. Now, another type of analysis would be a repeated measures ANOVA. And this is when you have one group that does the measurement repeatedly, more than once, either a pre-test and a post-test, or at time 1, 2, and 3. So that would be different than the analysis of variance that we did in the previous chapter. Now, we're going to skip over that this semester, and we're going to talk about more complex designs, which is a factorial ANOVA. So a factorial ANOVA is when you have two or more independent variables that are manipulated. And we'll talk about what those factors are on the next slide, but again, the independent measures ANOVA we did last chapter was one independent variable with multiple levels. Now we're talking about a factorial ANOVA where we have two or more independent variables, each with two or more levels. And here's my little meme, multiple levels of independent variables. Use factorial design, you must. So let's remind ourselves of what a factor is. So a factor is an independent variable in an experiment. So you can use these terms interchangeably. A level is one of the conditions of that independent variable. So the level is the number of conditions for a given factor. So the factor is the independent variable, the level is the conditions within that independent variable. And a factorial design is a research design that includes two or more factors. So a two-factor design has two independent variables. A single-factor design has one independent variable. Now, a single-factor design is what we did in the previous chapter when we did our independent measures ANOVA. That was a single-factor analysis of variance for between subjects designs. In this chapter, we're going to talk about two-factor designs and a factorial ANOVA. So now let's look at this. If we had a 2 by 3 by 2 design, how many factors do we have here? It's a three-factor design. This is one factor. This is a second factor, and this is a third factor, with a total of 12 conditions. So this is one factor with two levels. This is a second factor with three levels, and this is a third factor with two levels. So let's look and see how that would look on this next slide. So here we have two factors, factor A and factor B. Factor A has two levels. That's what's being shown here. Factor B has three levels, 1, 2, and 3. That gives us 6 cells, 1, 2, 3, 4, 5, 6. Now this is a between subjects design. That means we have 6 conditions already. But wait, what happened to our third factor? That's factor C. So it says factor C has 2 levels. So this is one way to represent this type of design. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different conditions for our three-factor design. There's level 1 and there's level 2. So as we saw on the previous slide, the two-factor design can be represented as a matrix. And we're going to limit ourselves to talking about two-factor designs in this chapter just for simplicity. As we also saw, each cell corresponds to a separate treatment condition or a specific combination of the factors. So here's an example that we're going to go over throughout the class. Ostracism has a powerful negative effect on individuals. face-to-face ostracism is not necessary for these effects to emerge. They occur also in the internet, ball toss games, and within chat rooms. In previous research, ostracized individuals observed the interactions between other members of a group. In this experiment, the authors tested whether the imagined ostracism is sufficient to inflict psychological pain. They used a triadic cell phone text messaging method such that after initial inclusion in a conversation, participants either continue to be included or receive no further messages from the others, and saw no messages between the others. Ostracized participants reported worse mood and reported lower state levels of belonging, control, self-esteem, meaningful existence, and wrote provoking messages. So this is how we could represent that 2x2 factorial design. Here's our factor A. This is one factor, group type. Here's our factor B, social interaction. And here's our two levels of each. So group type factor A has an in-group and an out-group condition. Social interaction, factor B, has an ostracism and inclusion condition. The levels of one factor determine the columns, these are the columns, and the levels of the second factor determine the rows. And that's important to keep in mind. So factor B, we're looking at the rows. For factor A, we're looking at the columns. So that's what this is showing you here. Here are factors, and I've just circled them. Social interaction is one factor. Group type is another factor. They have to call it factor A and factor B. Here, we're showing the levels for factor A. So factor A has two levels, or two conditions. Here, we're showing the levels of factor B. Again, factor B has two levels. So these data sets are going to provide three separate distinct sets of information. We have main effects and interactions. First, we're going to see the main effect of factor A, and that's going to be represented by the column means, the total column means. Then we're going to have the main effect of factor B, and factor B is our rows, so it's going to be the total row means. And then we have an interaction, which are the cells in between. And that's shown here, and I've tried to color code it the right way. So here we have group type, which we said was factor A, and that main effect is going to be represented by these overall means. So we'll have a mean for each condition, and then we have a mean just for the in-group, regardless of what type of social interaction they had. We have a mean for the out-group, regardless of what type of social interaction they had. And we compare these two means, this mean to this mean, our in-group mean to our out-group mean, for our main effect of factor B. For our main effect of factor A. For our main effect of factor B, we're comparing the row means. So here, yes, we have means for each condition, and then across group type, we have an overall mean for ostracism, and we have an overall mean for inclusion, regardless of which group type they were in. And we compare these two means, the total row means, to see if we have a main effect of factor B. And we look at the differences between these sets of means to determine if we have an interaction.